Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 1, Episode 17, and then this is the continuation, so this is Video 2. So, Video 1, we looked at implementing Google Sheets into, looking at implementing some of our topics of exponentials and logarithms into Google Sheets. And in this case, we're going to continue building off of that, and we're going to talk about now some of our log functions. So we learned that for the pH scale, we had pH was equal to log, it was negative log, negative log of the molarity of the hydrogen ion molecules. Hydrogen ions, I should say. And so, what's that? We can start with our thing here. So, I'm going to title this pH scale, why not? So, our input is going to be the molarity of hydrogen. So, I'm going to just, we don't need that, we'll just do H plus. So, there is our molarity, and we want to know what does the pH equal. So I'm going to use a question mark this time. So let's see, we need an example. Suppose our molarity, so example, suppose our molarity or concentration of hydrogen ions was, how about 3.2 times 10 to the negative 8th. Alright. So how would we implement that? Well, since this is in scientific notation, what I'm going to do is use the equal sign. So I'm going to, now if you recall from the last video, the equals is how we enter the equation editor. Okay. So now we're in the equation editor of Google Sheets. So I'm going to do 3.2. Then again shift and then number 8. That gives me my multiplication sign. So we have 3.8 times 10, and if we hit shift, number 6, that gives us our exponent. And then we need parentheses and a negative 8. And then I'm going to hit enter, and there is our 3.2 times 10, negative 8. Now to figure out the pH, we're going to use the equal sign, and then we need negative. And notice if I start typing log, in fact, you can see just the L, there's the natural log, then we have log right here, so log, and then what we need is log of our concentration. I'm going to click right here, and parentheses, hit enter. Notice we got a pH, so this tells us our pH is 7.49. Alright. So let's go ahead and do some formatting now. So, oh yeah, we want to. We'll do a nice little border here. So there's that. And then I'm going to do conditional formatting on this, so we know that this is our answer. So how about that? That way we visually keep track one of these this quantity here we know is our answer, what we're looking for, and this is what we got plugged in. It's just to help visualize where the answers are. Whereas if you don't do that, you have something like this, and it may not be clear what's going on. So that is one nice thing about color coordinating with that. Now, if we want to change the value now, so we know our pH is almost 7.5, so let's suppose it was 5 times 10 to the negative 3, right? So notice I went up here and I changed the values. You could have hit delete here, then retyped it to get this number, or you just click on this bar right here and just change the 5 and the 3. You can hit enter. And now, once we've done our edits in here, you hit enter, and notice that automatically updated for a new pH of 2.3. Now I'm going to edit this number. So let's look at what formats we got here. Notice we can do scientific formatting. I think we're just gonna make it do a number. Looks like 2 decimal places. Alright. So we have this around 2 decimal places. You can do custom number formatting and make it like 1 decimal place. There's many ways to go about this. So now suppose now you have the the pH is equal to, how about 4.7, and you're wondering what is the concentration, what's the molarity? Well, to do that, we're gonna make a line here. I guess we'll make it right there. So in this case, we have the pH, and we want to know what is our concentration of hydrogen ions. So I'm going to put a question mark here. So in this case, our example was, well, pH was 4.7, so let's put 4.7. And our hydrogen, so let's think back to our equation here. So I'm just going to use, how about P for pH? So if you have pH is equal to negative log of our molarity, and if we want to solve for that molarity, we want to think about this P as our input and then the molarity of hydrogen ions as our output. So I am going to multiply both sides by -1. So times, so negative P is equal to log of the hydrogen ion concentration. Now I'm going to raise both sides to the 10, or I need to exponentiate both sides. So we have 10 to the negative P is equal to 10 to the log of our concentration. Or we could think 10 to negative P is equal to our molarity, because these kill each other off thanks to our property. So this right here is going to be our equation we want to use. It tells us how to relate the pH with the molarity, where our pH is now our variable to plug in. So I want to hit equals 10 to the, I'm going to go parentheses, negative, and then click on my pH and parentheses, hit enter, and we got this really small number. We can click right here to adjust the size of the column, and we can see several decimal places. So to make this a more manageable value, we're going to go format, number, that freaked out again, so let's go ahead and make this bigger. Format, and notice we have scientific notation right here, so let's click scientific notation. Now that's convenient, I like that. So notice it rounded 2 decimal places. Whenever you see this E right here, some calculators, especially some scientific ones, use an E. What that says is 2 times 10 to the negative 5 power. Okay. Oops. So this, you want to read this 2.00 E negative 0.5. This is the same thing as 2.00 times 10 to the negative 5. Okay. It's just kind of a funky format that computers, calculators, some programs use. So just bear that in mind. And now let's get our formatting here. And let's go ahead and do our conditional formatting. And then, so there we go. So there's the pH scale, and we could do something similar for the decibel scale. So let's see, what was the decibel scale? We had our decibels was equal to 10 log of our intensity over our reference. So that's the decibel scale. We can make a similar setup here, but I want to make you think a little bit harder about what it is we're doing. So the decibel scale is this. The Richter scale said the magnitude was equal to log of I over I naught. So this was the Richter scale. We also have the moment magnitude scale, which said that our magnitude of an earthquake was 2/3 log of I over I naught. And well, let's throw the pH scale up here also. So pH was equal to negative log of our molarity. So when I look at this, we can generalize a pattern. So if we think about this, we have coefficients right here, right? We have our coefficients, we have our log, and then inside our log, we have a quantity. So all this is our quantity, and it's all divided by another value. So in this case, it's I naught, I naught, I naught. Right here, there's no value, so we can imagine a 1 right there. For the decibel scale, I naught was 10 to negative 12. For the Richter scale, it was 10 to negative 4. Moment magnitude was 10 to the 16. In this case, this is 10 to the 0. So when we think about this, we could think of all 4 of these as following the same type of function, right? And it all depended upon what is the coefficient. In this case here, we have a 10, a 1, 2/3, negative 1. You had the input of the intensity that was measured, or in this case, the concentration. And then you had the reference threshold. In this case, we had a 1 right here. So we can set up a general equation where we have a coefficient, and then we have our intensity, or in case pH that was concentration. So maybe we'll write it like this: intensity slash concentration. And then we'll just move this over a little bit so we get the full word there. And then we have a reference. And we'll say reference value. Alright. And it looks like we need to move that a little bit. So for the pH scale, we have our intensity, concentration, that would be the molarity, but our reference value is a 1. Okay. So if we want to do the decibel scale, our coefficient is 10. Our intensity, I don't know, we'll just make up something. How about 7? Well, we need to have equals because we're going to do scientific notation. How about 10? 7 times 10 to the, about negative 4 or 5. Alright. So there's some intensity, and then we know that I naught, in this case, since we're doing the decibel scale, was 10 to the negative 12. Notice how it rounded it to 0 there. That's just the display. It's not actually 0. It's just the number of display decimals is so small that Google's just showing 0. Okay? The value is still saved in there. So I guess we need to call this something. I don't know. What would be a good value? How about we just call it the answer? Make it simple. So let's see here. Let's go ahead and set up. We need to bracket this. Alright. So if we want to set this up, let's move this. Oh, we can X out that. We don't need that. So our answer, if we follow our general pattern, in fact, let's talk about our general pattern. So all 3 of these, so our answer is going to equal our coefficient times the log of, we think intensity over reference. Right? That was our generalization. In fact, let's go ahead and highlight this to show how everything coordinates together. So now we can see all the quantities relating to our general formula. I'm going to follow our general formula, so we want the coefficient times log of our intensity divided by our reference value, and hit enter. So here's our answer, and this is in the, for a call, the decibel scale, that is going to be in decibels, right? In fact, I'm going to format this to 2 decimal places. So that, there we go. So this says is if you are using the decibel scale, we've plugged in our I naught of 10 to negative 12 right here. And then we have our intensity, our coefficient. Now if we want to do the Richter scale, so imagine, well, we need to pick something other than 10, something greater than 10 negative 4, but so here for the Richter scale we notice we have a 1, so if we plug in a 1, and let's pick, how about, let's suppose our intensity measured was 125. Our reference value now we know is 10 to the negative 4, so I'm going to change that to negative 4, hit enter. And so this earthquake would have a magnitude of 6.1. And we can change these values to, so suppose our intensity is 125, we want to figure out what does that look like on the moment magnitude scale. So notice our coefficient is now 2/3. So when you use fractions, this is critical. Do equal sign first and then the 2/3. If you just do 2 over 3, it's going to convert it to a date. So if we look at format, see, it says it's September 3rd, 2020. That's bad. That will mess up your formatting. So to get rid of that formatting, you'll have to go format and clear formatting. Because whenever it sees that 2/3 or number/number, it's going to automatically think it's a date unless you put that equal sign in front. So for reference intensity, it has to be 10 to the 16, so let's delete that. Here's 10 to the 16. And notice we have a problem here. We have a negative value. We have a negative value because this intensity is not big enough. So let's just add some zeros. So times 10 to the, how about 30th? Oh, oops. I need an equal sign. So it got mad at me because I did not have an equals. So here's equals. Enter. So notice if we have 125 times 10 to the 30th, that's going to give us an earthquake of magnitude 10.73. Alright. So notice all 4 of our equations here follow the same general pattern, and we can modify our equation here to account for that. And if we really wanted to, we could do something even fancier. We could use a switch function so that we can hard program each of these intensities and coefficients into here using a switch, and then you could then not have to retype those. But I think we've hit a good time limit for this video. So thank you for watching. If you've enjoyed our content, please subscribe and support us on Patreon. Thank you for joining our math party, and in our next video we will look at another example of implementing these types of functions into Google Sheets. Alright, see you next time.